Okay, so we're going to do a quick video today on solving rational equations. Solving rational equations, we can think of that as just these 5 steps. Okay, first step is to factor the denominators of all of the rational rational terms. We're going to identify the restrictions on the domain. We're looking for restrictions on what can be the input variable into the equation. We are going to clear the denominators. Then we're going to have a resulting equation that we're going to solve. And then finally, we're going to look at our answers and make sure that our answers aren't answers that were in the restricted set. So our first example is going to be 2x on x squared minus 9. See if I can write that better. X squared minus 9 plus 3 on x plus 3 equals 1 over x minus 3. Okay, so our first step is to factor the denominators, all right? And that's going to look like this. We have 2x. The denominator here is a difference of squares, so that's going to factor as x minus 3, x plus 3. Then we have 3 on just x plus 3. Okay. That can't be factored, and neither can this last denominator, x minus 3. Okay, so now we're going to look for restrictions. Okay, so we're going to set each of our denominators equal to 0 and see what we get. Well, if we set x minus 3, x plus 3 equal to 0, well, we can see that this is just like a quadratic, right? Solving quadratic, we're going to have two cases. Zero product property says that x minus 3 equals 0, so x equals 3, and x plus 3 equals 0, so x equals negative 3. Now what this is telling us is that if we put a positive 3 or a negative 3 into our rational equation here, we are going to get an undefined situation. We're going to be dividing by 0. That's not allowed in math, so we have to say no to those two restrictions. So we're going to keep that in mind. We're going to come back to that after we solve the equation and see if any of our solutions are negative 3 or positive 3. Okay, so we're going to continue on. Now, to clear the denominators, that was step 3. We are looking for the least common multiple of the denominators. And to find that, we are going to make sure that every factor in the denominators, so x minus 3 and x plus 3, well, it turns out that x plus 3 and x minus 3 are over here too, that all of those are going to have to be factors of our least common denominator. Okay, and well, that clearly is just this expression right here, x minus 3, x plus 3. So what we're going to do is we're going to multiply every every term in the equation by x plus 3 times x minus 3. It's going to look like this. So we'll have x minus 3, x plus 3 times 2x over x minus 3, x plus 3 plus, well, same thing, x minus 3, x plus 3 times 3 over x plus 3. And we're going to do the same thing on the other side of the equation. X minus 3, x plus 3. Okay, this time it's just times 1 over x minus 3. Okay, well here's the fun part, right? We get to cancel out some common factors here. All of these are common factors. X minus 3 cancels with the denominator, x plus 3 as well. On the second term, we have that. On the second term, we have x plus 3 that cancels. And on the last, we have x minus 3 that cancels. Okay, I'm just going to rewrite this expression with what's left, or this equation. We have 2x plus 3 times x minus 3 equals, well, it's 1 times x plus 3, so it's just going to be x plus 3. Okay, so now we are on to step 4. We've cleared the denominators by multiplying by the least common multiple in the denominator, or the least common denominator. We've canceled our terms, and now we just have a linear equation. So to solve this, we're just going to distribute, combine like terms, and then isolate the variable. Okay, so I just distributed, get rid of the parentheses. Our next step is going to be to combine like terms. So we have 5x minus 9 equals x plus 3. I'm going to, I'd like to get my variables on the left, so I'm going to subtract x from both sides. I get 4x minus 9 equals 3. Add 9 to both sides, and I'm going to get 4x equals 12. Continuing on, I can divide by 4. Divide by 4, I get x equals 3. Uh-oh, that might be a problem, because if we think back to what our restrictions were, x equals 3, and x equals negative 3. If we put those into our original equation, they're going to make the denominator equals 0 in one of our expressions, or more, or sorry, one of our terms, or more than one of our terms. That is creates something that's undefined. So this particular solution is what we call extraneous. Okay, so we had one solution for this rational equation. That solution was extraneous. Therefore, this equation has no solutions. Okay, here we go. Our next example is going to be x plus 7 over x minus 1 plus x minus 1 over x plus 1 equals 4 on x squared minus 1. First step is to factor the denominators. Okay, so we're going to get x plus 7 over x minus 1. That was kind of messy. X minus 1 plus x minus 1 over x plus 1. Those denominators, the first two denominators, couldn't be factored, so we're just going to move on to the last. This is a difference of squares again, so we're going to end up with x plus 1, x minus 1. Okay. Looking for extraneous solutions, looking for restrictions. Restrictions will, So we've got our only factors in the denominator are x plus 1 and x minus 1. Well, this would be x equals negative 1. Here we're going to have x equals 1. Okay. Both of those would make our denominators equal 0. Therefore, they are restrictions. So if our answer is one of those, it's going to be an extraneous solution. All right, let's go back to our equation. We need to multiply. We're going to be on the next step, so let's multiply by the lowest common denominator, and well, we need to multiply by something that contains every factor in the denominators. Well, as we can see, again, this guy right here contains all of the factors that are in the denominator, right? Or in the other denominators. So I'm just going to multiply everything by x plus 1, x minus 1. Now, as I multiply by x plus 1, x minus 1, I'm going to cancel out factors right away, okay? So I know that if I multiply by this guy on the first term, well, this x minus 1 is going to cancel with this x minus 1. So I'm really just going to have an x plus 1 times x plus 7. Okay, so I'm going to have x plus 1 times x plus 7 plus, okay, and then if I'm multiplying by the second term, I can see that the x plus 1 in the denominator is going to cancel with this x plus 1. So all I'm going to have left is an x minus 1 times an x minus 1 in the numerator. Okay, and then on the right side, if I multiply the whole thing by the denominator, well, I'm just going to end up with the numerator. Okay, so let's go on and let's expand this these binomials here. So we've got x squared. This is going to be plus 1x plus 7x. So it's going to be 8x plus 7. Here we're going to have x squared minus x, so minus 2x plus 1 equals 4. I'm going to gather like terms. So I've got x squared, that's going to be 2x squared. I've got 8x and a minus 2x, that's going to be 6x, and then I have a 7 and a 1. So that's going to be 8 equals 4. It's a quadratic equation. So to solve quadratics, we have to we have to set it equal to 0. So I'm going to subtract 4 from both sides. 2x squared plus 6x plus 4 equals 0. Okay, so at this point, we need to factor. And whenever I factor, I always look for the greatest common factor. And I can see that a 2 goes into the first, second, and third term, so I can factor out a 2. Be left with x squared plus 3x plus 2 equals 0. Now, really, I'm only concerned with this expression, this factor right here, because 2 can never be 0. So I'm just wondering where this x squared plus 3x plus 2 equals 0. So to figure that out, I need to factor. Okay. So to factor that, I'm going to have again, it's a quadratic. Leading coefficient is 1. Right? There's a kind of an imaginary 1 sitting there. Therefore, I'm looking for two numbers that multiply to positive 2 and add to positive 3. Well, that's pretty simple. That's going to be 2 and a 1. Okay, so I'm figuring out where those are equal to 0. So I set both of them equal to 0. And I see that x equals negative 2, x equals negative 1. Okay, so those are my two solutions. but we have to make sure that we do step number 5 and check against our restrictions. And we can see that -1 is a restriction in the original equation. So because of that restriction, because we have this -1 restriction, we can say that this right here is extraneous. That's an extraneous solution. So our only solution is this x equals -2.